This is Mr. Castillo. In this video, we are going to review Grade 4 Illustrative Math Unit 2, Fraction Equivalence and Comparison. So, let's look at a problem here. It says write two equivalent fractions for two sets. So, to generate equivalent fractions, the rule is to multiply your numerator and your denominator. This is your numerator and this is your denominator. This is your numerator, this is your denominator. And we are going to multiply it by any number, as long as whatever we do to the numerator, we do also to the denominator. Whatever we do to the denominator, we got to do to the numerator. So we multiply each by the same number, by the same factor. So it can be 2, it can be 3, it can be 4, it can be 5, whatever you want. So since we are writing two equivalent fractions for two sets, I'm going to write two sets two times. Two sets and two sets. So we are going to generate two equivalent fractions. So I'm going to use multiplication, and we can even use division. So let's use multiplication first. Times. So I'm going to pick the same number for the numerator and the denominator. Okay, so let's say we're going to times it by 2. Okay, 2 times 2. So this is our equivalent fraction. It's 4. 6 times 2 is 12. Okay, so that means that 2 sets is the same as 4 12s. Okay. Let's do another one. So we can use multiplication again. Here, 2 sets. We can multiply by the same number on the top and bottom. So let's use 3. We may also use 4, 5, 10, whichever number you want. Okay, so we know that 2 times 3 is 6. We know that 6 times 3 is 18. Okay, so here we have that 2 sets is the same as 6 out of 18. And in cases like this, we can also use division. We can also generate equivalent fractions by using division. So we can use multiplication or division. The only thing about division is that you have to make sure that whatever number you pick to divide by your numerator and your denominator, it has to be able to go into both numbers. So for example, here, like for example, 6 is divisible by 3, right? But 2 is not divisible by 3. So you can't use 3. But we can use 2 in this case. So this, we can divide it by 2. We can say 2 divided by 2. And we can say 6 divided by 2. And precisely, we're going to get 2 divided by 2 is 1. 6 divided by 2 is 3. So 2 sets is also equivalent to 1/3. And speaking of that, let's look at the next problem. Okay. Luis says that 2 sets is also equivalent to 3 9s. Do you agree with him? Explain. Okay, so we just learned that 2 sets is what fraction? Is equivalent to what? Well, we just learned that 2 sets is the same as 4 12s. We just learned that 2 sets is the same as 6 18. And we just learned that 2 sets is indeed the same as 1/3. Okay, well, wait a minute. It's saying here that 2 sets is equivalent to 3 9s. And let me see what happens if I use multiplication. Like I said already, equivalent. Let me see, 2 6. Oh, if I times it by something, am I gonna get to 3 9s? I cannot multiply 6 by anything to get to 9. That's not possible. So this is not gonna work, right? So it's not directly related via multiplication, okay? But what we do know is that 2 6 is the same as 1/3, okay? Because we can do 2 divided by 2 and 6 divided by 2, and that gives us 1/3, just like we saw it over here. 2 6 divided by 2 equals 1/3. So now, is 1/3 the same as 3 9s? Well, you should be able to notice a direct relationship. For example, we can say that 1/3, is it possible for this to become 3 9s? Let's see. How does 1/3 become 3 9s? Well, 3 times what will give you 9? 3 times 3 is 9. Whatever we do to our denominator, we have to do to the numerator. 1 times 3 is 3. So there you go. So I generated an equivalent fraction for 1/3, and it is 3 9s. It's the same thing. Okay. It's like if you would draw this, if you would draw 1/3. Okay, this is 1/3, right? And I'm gonna shade it to show you 1/3. Okay, 1/3. Next, I'm gonna break it. I'm gonna break it to show you how this became 2 6. It just became 2 6 right now. Look, 1 2, 2 parts out of 6. Okay, so 1/3 is the same as 2 6, as you can see there. Now, how does it become 3 9s? Okay, well, let's see. So each 1/3 was broken up into 3 parts. That's what happened. So let's see. Oops, there you go. So this is the original 1/3. So if we break it up in 3 parts, if we multiply by 3, if we multiply each third by 3, that means we make it into 3 parts like this. Now the same 1/3 here, this same 1/3 is 1 2 3, right? 3 out of 9, right? 1 2 3 4 5 6 7 8 9. So now this model shows 3 9s. You see, it's the same as the 1/3. And also, another way to look at all of this is that you can simplify this. You can simplify both of these into the same fraction. So can we generate the same equivalent fraction for both? So let's say that 2 6, we have 2 6 here, and we have 3 9s here, because Luis says they're equivalent. We have to test it out. So let me see. Let's generate an equivalent fraction by using division this time. So divided by 2, and it's equals to 1/3. We saw that already. Now let's see what happens here. Should we divide this by 2? No, because 3 doesn't go into 2. But we can divide it by 3. 3 goes into 3, and also 3 goes into 9. 3 divided by 3, whatever you do to your numerator, you have to do to your denominator. Okay? And whatever you do to your denominator, you have to do to your numerator. Okay, 3 divided by 3 is 1, and 9 divided by 3 is 3, because 3 times 3 is 9. So indeed, Luis is correct. So I will say that I agree with Luis because I was able to generate equivalent fractions, and I showed that both of these fractions are the same as 1/3. Okay, let's write a comparison statement with these fractions by using the symbols for less than or greater than. So first, we're going to choose two fractions and write a comparison statement. And we're going to explain or show our reasoning. So we're only going to choose two fractions. So we can pick any two really. But let's go with the obvious easy ones. Okay, so I like this one. So let's choose this one, 5/3, and let's choose something like this one, like 3/10. So I think that 5/3 is greater than 3/10 because I know that 5/3 is greater than 1/2, because I know that 3/3 is 1/2. So 5/3 is more than 1/2. I know that 3/10 is less than 1/2 because I know that 10/10 is 1/2. As a matter of fact, this fraction is less than 1/2 because I know that 5/10 is 1/2. So this fraction is definitely bigger. So 5/3 is definitely bigger than 3/10. Well, pause the video and try it out for yourself. Okay, so let's say I'm gonna pick 5/6 and 7/8. So let's say I pick 5/6 versus 7/8. Okay, let's see which fraction is greater. So I can say it to myself. There's two ways to look at this. You can either use benchmarks or you can use equivalent fractions. I would say that 5/6 is less than 7/8. Let's see why. Okay, so I'm going to use benchmarks. So both of these fractions are more than half because I know that 3/6 is half. So this is 5/6. Both of these fractions are more than half, and both of these fractions are less than 1. This one is more than half because I know that 4/8 is 1/2, and this is 7/8. So both of these fractions are off the whole by 1. So this one is 1/6 away from 1/2, and this one is 1/8 away from 1/2. away from one whole means like imagine that this is the number line, okay, and there's the one whole right here. There's 0, and 5/6 is like over here. Imagine that is here. Imagine that 5/6 is here, and you are 1/6 away from one whole. And 7/8. Imagine that we have another a similar number line of the same size. This is 0, and this is 1. And imagine 7/8 is right here, and you are only 1/8. You are only 1/8 away from 1. So which fraction is smaller? So which is a shorter distance away from the finish line, away from the whole? And I can see that because I know that 1/8 is smaller than 1/6, then 5/6 has to be a smaller fraction than 7/8 because this is a smaller portion away from one whole. So go ahead, take out a blank piece of paper and a pencil and give this a try for yourself. Okay, so let's say that you paid something like 5/6 and 2/5. So I would say that 5/6 is greater than 2/5. Or I can also say that 2/5 is less than 5/6. Let's see why this is true. First of all, let's look at it using fraction benchmarks. So I know that 3/6 is 1/2, right? So I know that 3/6 is 1/2 because 3 is half of 6. So 3 out of 6 is the same as 1/2. And in here I have 5 out of 6. So 5 out of 6 is more than 1/2. And 2 out of 5, 2/5, I can say that it's less than 1/2. And a fraction that is more than 1/2 has to be bigger than a fraction that is less than 1/2. Okay, so I hope that you understand why 2/5 is less than half. Because let's say that you have 5 tens. Okay, let's draw 5 tens. Let's say 5 circles here. 1, 2, 3, 4, 5. Okay. If I only select 2 out of the 5 circles, do I have more? More than half or less than half? Well, I have less than half. Because half of 5 is neither 2 nor 3, but it is about 2.5, right? That is half of 5. So 2/5 is less than half. So a fraction that is more than half is greater than, or a fraction that is less than half. And let's say that you compare this by using equivalent fractions. That is another way to do it. Then you will find a common denominator between 5/6 and 2/5. One way to find that common denominator is by writing the multiples of each. Let's see. Let's write the multiples of 5. And let's write the multiples of 6. So 5, 10, 15, 20, 25, 30. And I want to start right here because I know that this is a multiple of 6. Okay? 6, 12, 18, 24, 30. So we can see that 30 is a common denominator between 5/6 and 2/5. So I want 5/6. I want 5/6 to have a denominator of 30. And I want 2/5, and I want 2/5 to also have a denominator of 30. But how did I get there? 5 times what gives me 30? Well, I know that 5 times 6 gives me 30. And I also know that whatever I do to the bottom, I have to do to the top. So 2 times 6, that's 12. So here, 6 times what gave me 30? Well, that was a times 5. We'll also do it over here, times 5. 5 times 5 is 25. So 5/6 actually turned out to be 25 out of 30. And 2/5 turned out to be 12 out of 30. So you can see how 25/30 is bigger than 12/30, such that 5/6 is greater than 2/5.